So, volume section of your revision sheets, it says, for the Christmas market, a confectioner has created a chocolate Santa. It consists of a solid hemisphere topped by a solid cone. Both have diameter of 5 centimetres and the height of the cone is 4 centimetres as shown in the diagram. Calculate the volume of chocolate required to make one chocolate Santa, giving your answer correct to 3 significant figures. Now, information that you really need to know for this question is the volume of a sphere is 4/3 times pi r cubed. You're given that formula, so you don't really need to learn it. But you're not given the volume of a hemisphere. But that's just half your sphere. So you take your 4/3 pi r cubed and you divide all of that by 2, and that gives you your volume of the hemisphere. You're also given the formula for the volume of the cone, which is 1/3 pi r squared times h. Now, we're going to start off and we're going to work out the volume of that hemisphere, and I've labelled it just a 1. So volume of the hemisphere, volume HS hemisphere, is 4/3 times pi times r cubed, but I've got to divide the answer by 2. Now, I'm looking here, that there is right across the hemisphere, so that's the diameter, and if you draw that right down there, it's a D line on its side. So that's D for diameter. I don't want the diameter as 5. I want the radius. So to get the radius, what we do is we halve the diameter. So the diameter is 5, the radius must be 2.5. Okay, and I'll just write that in there. Now, all we have to do is sub all of that into a formula. So we've got 4/3 times pi times 2.5 all to the power of 3, and whenever I've got the answer to that, I divide it by 2. So put that into your calculator, check your answer. It comes out to be 32.7249, and it goes on and on and on. Now, you are asked to write your answer to 3 significant figures, so 1 full mark in this question will be for rounding. So 3 significant figures just means that we start at the biggest number and we underline 3 of them. So basically, I want to round it to there. So I'm chopping off a wee 2, don't need to worry about it. So to 3 significant figures, the volume is 32.7 and volume is measured in centimetres cubed. So that's the first part of it done. Now we want to get the volume of the second part. I'll put that wee one back in there. So that's the volume of your cone, and that's the second bit. So volume of a cone we know is 1/3 times pi r squared times h. The radius is the same, so it's 1/3 times by pi times by 2.5 all squared, and make sure we've got the height of the cone, and the height of the cone is 4. Okay, now sometimes they give you a full height, and I'll speak about that right at the end. So we're going to put all of that into a calculator and see what we get. Okay, when I've put that into my calculator, I get 26.1799, and it goes on and on and on. Units are centimetres cubed. Again, 3 significant figures, underline the 3 figures starting from the biggest one. We're rounding it to there. And when I round that to 3 significant figures, it's 26 point, it's a big 7, so that makes that jump up to a 2. Now, all I have to do now is, I've got to do the total volume to get the full volume of that chocolate Santa. So total volume, add both of them together. So I've got 26.2 and I want to add on 32.7. When I add them together, I've got 7 and 2 is 9 in the decimal point, 2 and 6 is 8, 3 and 2 is 5. So it's 58.9 centimetres cubed. This one is the same shape. It's got a cone and it's got a hemisphere. But I'm going to point this one out to you because there's the height of the cone is from there right down into the middle of that bit. Okay, but they've told me that the whole height, the total height there is 27. So I don't really want this bit in here. So I want to chop that off, but that's the same as the radius. And the radius, we know, is 12 centimetres. So if I take the radius off that height, I'm taking 12 away from 27, which is going to leave me with 15 in there. So the height is 15 centimetres. Now, the question's done exactly the same. We know the radius. Okay, so there's the radius there. If you think of that as a three-dimensional shape. So to get the height of the cone, take the radius away, and it leaves you 15. Okay, but everything else is done exactly the same way. Okay, another variation of this one. You want the total volume. And what have we got? We're given two heights. So I'm given the height of the cone. That's the height of the cone is 25, and the total height of the shape is 32. So the other bit that's left there, this bit in here, must be 32, take away 25, which leaves me with 7 centimetres. So that means the radius of this thing is 7 centimetres. The height of the cone is 25. Okay, so it's just wee variations and things that you could be asked. So that's the height of the cone. Okay, and again, it's all done exactly the same way as your first revision sheet. Okay, question 2 on volume. So it says, sherbet in a sweet shop is stored in a cylindrical container like the one shown below. So it's diagram 1. It says the volume of the cylinder, correct to the nearest 1000, is 10,000 centimetres cubed. It says the sherbet is sold in conical containers with a diameter of 5 centimetres as shown in diagram 2. 250 of these cones can be filled from the contents of the cylinder. Calculate the depth D of the sherbet in the cone. Right, so we know that the volume, they've already told me what this is, they've worked it out already. Right, so the volume of a cylinder, we know the volume of a cylinder is pi r squared times h. But they're telling me the answer to that, so I don't need to work that out. So I don't know why they've given me all these values. So it says there's the volume. So I know that the volume of that is 10,000 centimetres cubed. Now that amount, that 10,000 is going to be split into 250 of these cones. So the volume of each cone has got to be that divided by 250. So that's 10,000 divided by 250. And when we divide them out, there's 4, 250 is 1,000, so it must be 40. So there must be 40 as the volume of each wee cone like that. Okay, so total volume was 10,000. It was split into 250 of those cones, so the volume of each cone has got to be 40. Okay, so volume of each cone is 40, and it's going to be in centimetres cubed. Now, we're asked something back to front this time. It says calculate the depth. That's the same as the height of the cone. So the only thing we know about the height of a cone or the volume of a cone is the volume is equal to 1/3 times pi r squared times h. So h is what we're trying to find. It's the same. That's the same as h. So I want to find this thing here. I'm going to substitute every single thing in that I know. Okay, so I know the volume of the cone is 40. So I'll put that in there. That's equal to 1/3 multiplied by pi multiplied by the radius squared. There's diameter is 5. There's d for diameter, so the radius has got to be 2.5. So it's times 2.5 all squared multiplied by h. So I'm going to work all of this out. I'm going to put all of that into my calculator, so I'll just put a wee highlight through that. I'm going to work that whole bit out in my calculator. So I'm going to do 1/3 times pi times 2.5 all squared. So I'm going to do. So when I've put that into my calculator, then I've got an answer of, so this green part comes out to be 6.5498, etc. So I'm going to stick it into this formula. So the green bit turned out to be 6.54498. Just stick it, it's a whole big number, okay? And that's multiplied by h. So I want h, I'll read it round the other way. So 6.54498 multiplied by h is equal to 40. I just want h on its own, so I don't want that multiplied by that big number to be there. So the opposite is to divide by it. So h is 40 divided by 6.54498, and that does go on. You can use the full number if you want in your calculator. So 40 divided by, and I'm going to use that full big number, and it turns out to be 6.111, and that goes on, and that's centimetres because it's a height. It didn't say to any number of decimal places, so if we're talking about centimetres, it's probably okay just to put it to one decimal place, because that's millimetres, which are quite small. So 6.1 centimetres is the height of that. Right, so I'll go back through that again. Okay, so we know, although they gave us dimensions in that, they told me the answer to the volume of that, so I didn't need to work it out. So they told me to the nearest 1,000, it was 10,000 centimetres cubed, so I'm just going to use that. So that 10,000 centimetres cubed that we had, that's the amount of share bit in there, it's got to be poured into 250 of them. So I'm going to share that volume out by 250. So 10,000 divided by 250 means that each one of these wee cones gets 40 centimetres cubed. So that's a cone. The volume of a cone, I know, is a third pi r squared times h, and you should be given that formula. So I'm going to fill in everything we know, because we're kind of working backwards in this one. So the volume is 40, pi, a third times pi times 2.5 squared, I'm going to work out. So I stuck all of that into my calculator and got this 6.5, etc. The h is still sitting in there. I read it round the other way, so 6.54498 times h is 40. I don't want it multiplied by this big long number, so I divide by it, and it gives me the height of the cone.